Hi, and welcome to the How Do I BI mini-part screencast series on SQL Server Analysis Services based on my book, Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, Developer Evangelist with Microsoft in Southern California. In this edition, we're going to look at the procedure for implementing lift charts for data mining models and structures that you've constructed in BIDS. Before we do that, I'm going to talk about the FAQs and gotchas. The first one is that using a lift chart is not required. You may or may not be familiar with the lift chart concept. It's a visual output which allows you to see the validity of the algorithm results versus random guessing and perfect score. Where this information comes from is holdout data that you must either create when you create the mining model, which is a new option in the wizard in 2008, or simply by holding out a set of data with known results that you can use for comparison purposes. You can set filters on this data as well, and I'll be showing the process on how to do that during the screencast. Lift charts are particularly useful when you've set up multiple algorithms and multiple mining models against a single set of content data so that you can understand which ones produce most meaningful results. The gotchas in terms of lift charts are the validity of the lift chart results depends on the quality of the test case data. This will predict for all values and all states of all values by default, and I'll show in the screencast how you can adjust that and how you can filter. Also, profit charts are contained in the same area, and I'll be doing a separate screencast in just a couple minutes about profit charts. So now we'll go to the screencast. In this screencast, we're going to take a look at how lift charts work when evaluating the effectiveness of the data mining models that you've created in BIDS. To do this, I've opened BIDS and loaded the sample AdventureWorks and opened the targeted mailing mining structure, which contains multiple models and is a really good sample for us to understand how mining accuracy charts work. There are two types of accuracy charts, as I said in the introduction, both lift and profit charts. So you'll see in this mining structure we have four different algorithms, four different models based on Microsoft decision trees, Microsoft clustering, Naive Bayes, and a neural net. So I'm going to go over to the mining accuracy chart tab, and you'll see all of the mining models are available here, and we could deselect if we weren't interested in evaluating any of them. And they're all showing a single predictable column name because that's the only predictable column that we've set in the mining model. If we had more than one, we could select from it. By default, all values will be predicted, and I'll be showing you how the results can change depending on if you're looking for all values or you're looking for a particular state of the predictable. In our case, whether somebody has purchased a bicycle or not is a 1 or a 0. What you need to do in order to be able to use the lift chart is you have to have some data where the answer is known, and that is often called holdout or test data. Now there are two ways to get that. You can simply save that data as a data set, and that's what I'll be doing in this example, or you can use test cases. A new enhancement to SQL Server 2008 is available when you actually use the wizard to create a mining structure, and I'll show that briefly here. To remind you of how that works, I'll right-click on Mining Structure in the Solution Explorer and open the new Mining Structure dialog box and click Next and select from an existing relational database or data warehouse and select Decision Trees and select DIM Customer as our source table and select a couple of inputs and a predictable of commute distance, and then I'll select, I'll just agree with all of the selections for content and data types, and then you'll note that in the wizard we have this new property sheet which by default holds out 30% of the data for testing, and you can adjust the value by percentage or by rows, and this is a quick and easy way to create holdout data, and we've added it at customer requests. So I'm going to go ahead and cancel this and go back to the mining accuracy chart, and in our particular case, if we wanted to specify a different data set, which is the default, we would have to manually do that, because if I click on lift chart at this point, I will actually get an error because there's been no mapping to a data set, and the error is telling me I'm not knowing how to make this comparison because there is no mapped data set. So I'll open the build dialog box by clicking on the build button, and then from the specify column mapping dialog box, select input table section. I'll click on the select case table, and in the select table dialog box I'll then select the V target mail view and click OK, and then the column mappings will be automatically made to the mining structure attribute names based on the column names. If I wanted to make some adjustments, I would simply click on the black lines that indicate the column names and then right-click to open the context-sensitive menu, and then click on Modify Connections, which would open a Modify Mapping dialog box where I can make adjustments between the source columns and the table columns that are being compared. I'm not going to make any changes, so I'm going to click Cancel here. I'm going to click Close here. And then I'm going to, at this point, simply display the lift chart for all the possible predicted values. So once I click on lift chart, it'll take a minute to render, and the resulting chart will display the random guess value for the predicted results and the perfect value, and then it will display the values for each of the associated mining structures. And you can see in our particular case the mining structures aren't scoring very well because the ideal model is here, and the most appropriate model is the decision trees, which is scoring, according to the mining legend, 81%, or 0.81, which is 42% of the population has been scored correctly versus the training data with a predict probability of 74%. So you can use the visual output, or you can use the mining legend, or a combination to understand which algorithms are going to be appropriate for your particular business scenario. It might not be granular enough to look at all output values, so we're going to go back to the input selection, and we're going to select the predict value of 1 for all of the mining models, and then we're going to use another capability here. We're going to add a filter expression. We're going to click the Open Filter Editor to open the Dataset Filter dialog box, and we're going to set up some conditions to filter on. So the first condition that we're going to add is from the target male, and then we're going to open the child dialog box, and we're going to select the column age, and we're going to set the operator equal to age 35, and then we're going to set another condition. We'll set the gender equal to female, and then we will click OK, and this will limit the results that we're going to see when we see the lift chart evaluating our mining models. So now we click on lift chart, and we can see that the output is substantially different, and we can visually, and we can also pull the mining legend over and take a look at the scoring, which is a result of the total population. Decision trees is now 64% of the target population, and the predict probability is 50%. So lift charts can be a very valuable tool when you're trying to figure out how to tune your mining models, and you'll be reminded, as I showed in previous screencasts, that you can tune by adjusting the columns or attributes that are included, adjusting the content types, discrete, discretized, so on and so forth, and even selecting different algorithms. In the next screencast, we'll take a look at profit charts. Thank you.